Today we are going to discuss an important study related to the power system, and that is load flow study. The first important point related to the load flow study is that it is related to the steady state or balanced mode of the power system. See, unlike the fault analysis, this load flow study, it is related to the steady state or the balance mode of the power system. The fault analysis that we do, it is related to the faulty state, okay, or I can say unbalanced mode of the power system. But this load flow study, it deals with steady state mode of operation of the power system. Okay. Second point, what actually we do in load flow study, or what actually I'm getting after carrying out the load flow study on the given power system. Basically, it is a process of obtaining, basically it is a process of obtaining the four important and various quantities at the various points in the power system, and of course that power system is operating at steady state condition, and those important quantities are voltage, phase angle, real power, and reactive power. Okay, so carrying out a load flow study on a given power system is nothing but it is simply a process of obtaining these four quantities. What are these four quantities? Voltage, phase angle, real power, and of course reactive power. Now, how this knowledge of these four quantities helps to the power system engineer? It helps to ensure the smooth operation as well as the smooth control of the power system. Being a power system engineer, if I know these four quantities, of course, at various points in the power system, then I can ensure the smooth operation as well as the smooth control of the power system. To ensure the smooth operation and smooth control of power system. Okay, so this is the general idea, or this is the basic idea of what exactly we are doing in the load flow study. Okay, the first thing that you should know, that you should remember about the load flow study is that it is related to the steady state or the balance mode of the power system. Second thing is It is actually the process of obtaining voltage, phase angle, real power and reactive power at the various points in the power system. And of course, knowledge of these 4 points at various points in the power system will help to ensure the smooth operation and smooth control of the power system. Of course, we can, if I have the knowledge of these 4 quantities, then I can monitor my power system. As I said in this third point, I can monitor my power system for the smooth operation and for the smooth control. Okay, so but what happens is the power system, practically what we have, the parameters or the load on that power system is continuously changing. Load is not going to be the constant on the power system. So power system is continuously changing its state. So this load flow study is actually, it is not carried for a longer time, for a quasi state, for very small duration of a time. We take this, we do this load flow study, and we obtain these 4 parameters at the various points in the power system, and with the help of those 4 parameters, we decide the operation and we decide any control action required on the power system to ensure the smooth operation. Okay, this is the important point related to the load flow study. Again, the power system, what we have is, day by day we have to expand our power system. See, basically power system is nothing but it is a integration, or it is a combination. It is an integration, or I can say it is a combination of 3 important things: generation, transmission, and at the end I can say distribution. Is it? This is related to generation, it is transmission, and let's say it is distribution. And power system is nothing but integration of all these three systems. Integration of all these three systems will give me power system. Okay, so what happens, as the load increases, I need to expand my power system. What I'm saying, as load increases, as a result of that, in order to ensure the continuity of the supply, I must expand my power system. Power system must be expanded. See, if we take the example of India, at the time of the independence in the year of 1947, the total installed capacity, the total installed capacity in 1947, it was just 1360 megawatt, and the total installed capacity, total installed capacity as on December 2020, it is somewhere around 374.2 gigawatt. You can see how drastically the load has gone up. It is not increased suddenly, it is increasing gradually, but over a period of time, we can say load is increasing day by day, because of course we are building new, constructing new towns, we are setting new cities, we are making new industries. So of course load is going to increase on the power system. So as the load increases, I might need to add a new generator to fulfill the load. See, I can write here as load increases to fulfill or to maintain the continuity of the supply, I might need to add a new generator or transmission site or a transmission line, and of course a distribution network I might need to add in my power system. So in order to know the effect of adding this new part on the power system will of course will result into some effects on the existing power system. If I'm going to add a new generator, if I'm going to add a new transmission line, or if I'm going to add a new distribution network in my power system, of course it will have some effects on the existing power system. I can write here, it will have some effects on my existing power system. Okay, so in this regard, how load flow study is going to help me, that I'm going to state now. If I know those four parameters, then I can analyze. If I know those four parameters, in that case it is easy for me to analyze the effects of adding new system to the existing power system. Okay, I can analyze this thing. What I can analyze, I can analyze the effect. See how I can analyze this effect, that I'm going to tell you now. For that I'll take a very simple example. Let me take an example of, I'll give you an example. Let us consider a four bus system. Let us consider a four bus system. I'll draw that system here. And these four buses, they are interconnected with each other. Okay, let's say this is bus number one. Let's say this is bus number two. Let us say this is bus number 3, and let us say it is bus number 4. Okay, this is suppose my existing power system. Okay, and of course on this power system, definitely will have some generator connected. Okay, let us suppose that on the bus number 1 and on bus number 3 I have a generator, and on bus number 2 I got a generator as well as a load. Okay, and on bus number 4 I got load only. Okay, if I carry out a load flow study on this power system, on this existing power system, then definitely I will know those four quantities, that is voltage, phase angle, real power and reactive power on each of these four buses. Okay, now as the load is increasing, suppose I got one more load here. Suppose on bus number 3 I've installed one new load. On bus number 3 I have installed a new load. So of course there will be a requirement in this system to add a generator. There will be a requirement in the system to add the generator. If I know those four quantities at these various buses in the system, then I can analyze the effect of adding a new generator on these buses. Okay, I can analyze the effect of adding a generator. If suppose if I add a generator on bus number 1, what will be the effect on the existing power system? I can analyze that. If I want to install the new generator on bus number 2, I can analyze the effect of adding the generator on that bus. Same way, suppose if there is a requirement of adding a new transmission site, suppose I need to add a transmission link between bus number 1 and bus number 4. I can analyze the effect of adding a transmission line between bus 1 and bus 4. So I can as I'm able to analyze the effect, so I can decide the best location for addition of the new generator. It will be easy for me to decide the best location for adding a new generator. On out of these four buses, I can easily decide on which bus should I install the new generator. Or if suppose if there is a requirement of adding a new transmission line, then also it will be easy for me to decide between which two buses I should install the transmission line. So this is what this is what it is stated in this statement, that it will help me to analyze the effects. It will help me to analyze the effect of adding a new system in the regard here it is related to new generator or a transmission line. Okay, if you know the effect, you can decide the best location for that. Okay, this way load flow study will help you. Of course, over a period of time we need to expand our existing power system. In expanding this power system, of course we need to add some new systems in our existing power system. So this will help us to decide regarding the expansion of the power system. Okay, so this is related to the, it gives the basic idea, this discussion gives the basic idea what exactly the load flow study means, what exactly we are doing in load flow study. This discussion gives this idea. Okay, now let us know how we do the load flow study. Let us try to understand the process of load flow study. Let us try to understand the process of the load flow study. See, here we are concerned with finding those four parameters. The parameters are voltage, phase angle, real power, and reactive power. We are concerned with finding these four parameters at various points in the power system. So what is done here? Whatever power system we have, it is very difficult to analyze this actual power system. It is very difficult to analyze this actual power system to find out these four quantities. So that is why what we do in the process of power load flow study, what we do, we model the power system into simple electrical network. We model the power system into a simple electrical network. But what happens here, while modeling the power system into a simple electrical network, what happens? The generator which are connected in the power system, they behave more like a power source instead of a voltage source. I'll write that point here. While modeling generators behaves like a power source complex power source, I must write here, complex power source instead of voltage source. Secondly, the load, whatever load connected in the power system, actually when we talk about the load, we express the load in terms of impedance. If it is a complex load, we express that in terms of impedance, or if it is a resistive load, we express that in terms of some ohmic value. But what happens when we model the power system into an electrical network, the load is represented as complex power absorbing source. Okay, it absorbs the complex power. Instead of representing with the impedance, it is represented as, see, load, it is represented as complex power absorbing source instead of impedance. See, these two are the reasons why whatever electrical network we get after modeling the power system into an electrical network, these are the two reasons why we cannot directly analyze this electrical network as well. Okay, these are the two reasons why we cannot directly analyze this modeled electrical network of the given power system. That's why what we do to carry out, that is these are the two reasons why to carry out load flow study, Earlier, AC analyzer were used. In early days, before I can say 1940s, these AC analyzers were used. But the problem with this AC analyzer was, even if I'm going for a load flow study, if I'm going to use this AC analyzer to carry out a load flow study of a system which is having somewhere around 14 to 15 buses, it becomes very difficult for the AC analyzer. It takes very much time. Okay, so what happens with the development in the technology nowadays? We have computers with us. We have computers with us. So what we do, we use some mathematical algorithms, and we take the help of digital computers to solve those algorithms. Okay, so in these days, digital computers and mathematical algorithms are used to carry out load flow study. Okay, so this is all regarding load flow study. Okay, so in next lecture we will discuss network model formation. Thank you very much.